Now we're going to want to put a thermodynamic imprint on this examination of mixing. And that means then that we're going to want to look at the question of whether mixing happens by starting with the Gibbs free energy equation, because that's the equation we always use when we want to know whether something has happened. We're going to be looking at delta G of mixing, which means we have to look at delta H of mixing and delta S of mixing. This is not complicated at all. It's no different than when we were looking at phase transitions. And we'd say, oh, we're looking at a phase transition. Well, we need to look at delta G of vaporization, or delta H of vaporization, or delta S of vaporization, and then think in that term. All right, so now that we're going to be looking at mixing, looking at delta G, delta H, and delta S, the first thing we have to do, of course, is ask ourselves questions about the signs. What are the signs for this thing going to look like? And we can appreciate that the delta G mixing sign isn't any different than anything else. If, in fact, something happens, delta G is negative. So when I was able to dissolve a salt in water, it was soluble in water, delta G was negative. When I couldn't dissolve it in water, delta G was positive. When I was able to achieve miscibility between two liquids, as they made a homogeneous solution, delta G was negative. When I formed two layers, oil and water, I said delta G was positive. If I can't dissolve gases in water, delta G is positive. If I can dissolve them, delta G is negative. So that argument there about what delta G is, positive or negative, does it happen, does it not, is going to hold true for mixing as well. Let's talk about delta H and delta S and what they are. Remember, the delta H and delta S, which contribute to delta G, can form four possible combinations with each other. Positive and positive, positive and negative, negative and negative, and negative and positive. So it's no different than anything else that we've looked at. And in fact, if you can remember back to when we looked at phase changes, for example, you'll remember that in that particular case, those were some interesting examples where there was a temperature dependence to the phase change process, because it turned out the signs were the same. We're going to see something similar happening here in just a minute. And if you want to get a sense about that, just think about the idea of dissolving salt in water. Everybody dissolves salt in water. And they also always have this experience I'm going to tell you about. When you dissolve salt in water, if it sits on the stove at room temperature, you notice that there's a lot of salt sitting on the bottom of the container. Then you heat the solution up, and as you heat the solution up, suddenly the salt dissolves in water. And you go, hey, as I increase the temperature, the salt dissolves in water. It goes from not happening to happening. Oh, that's a temperature-dependent phenomenon. So you see that even with delta S of mixing and delta H of mixing, you have the same kinds of arguments that you can make about whether something happens that you did when you were looking at phase changes.